Okay, we're going to talk about piecewise functions today. Sometimes in real life, functions are represented by a combination of equations, each corresponding to a certain part of the domain. Such functions are called piecewise functions. For example, if you are some jobs that are commission, they have a base salary, and say you didn't sell anything, you would only get your base salary. But let's if you do sell something, usually it's after a certain amount of time that you get to get commission. It's above and beyond a certain amount. So you might have a jump in your a graph of what your salary might look at like if you were going to all of a sudden you have a flat base and then oops, you got commission that week 2 or something and it jumped up. So there might be different chunks, different rates of change during a function. That's what this is about. Now this is a much more not so applicable to real life as what I just said, but remembering that f of x is the same thing as y, it's just like two pieces, two lines is what this is. This would be, the first part would be the y equals 3x minus 1, and that's for values of x that are less than or equal to 4 is what it says. Then f of x is, this would be y is equal to 2x plus 7 for values of x greater than 4. So what we're going to do first off is just learn to evaluate using this function rule. So f of x, the function, is for values of x less than or equal to 4, you're going to use the top equation. For values of x bigger than 4, you're going to plug it into the bottom equation. Okay, and evaluate. So you say when x is 10, which one will we plug it into? Now, x bigger than 4, so I'll plug it in the second one. So that would be 27. Number 2, we have x equals negative 1/3. That's smaller than 4, so we plug it in the second one. 3 times negative 1/3 would be negative 1. Negative 1 minus 1 is negative 2. The third one for x is 4. The first equation, we have to, some of the people have been having some difficulty, I think, still don't really understand what these symbols mean, so I'm going to write it down again. This means less than or equal to. So it's red, less than or equal to 4. So this one says to evaluate when x is 4, so you'd be plugging in on the first one because that's the one that includes 4. So it'd be 3 times 4 minus 1. That's 12 minus 1, so the answer to that part is 11. X is negative 2 is a value that is also less than 4, so it goes in the first equation, and we do 3 times negative 2 minus 1. That's negative 6 minus 1. The answer would be negative 7 then. I am plugging these rather quickly because it's just basic plug and chug. 5.2 is greater than 4, so we go to the second equation. Okay, and we are going to substitute, because that's the one that says for all values of x greater than 4 and not including 4. So if I put in 5.2, I have to do 2 times 5.2 plus 7. And that's 10.4 plus 7, 17.4. So far, so good, I hope. All right, so next. Does anybody still need this page? All right, more practice. So now we've got 3 different functions. They don't all have to be f of x. This is f of x, g of x, and h of x. 1, 2, 3, and 4 are asking us to plug into the f function. 5, 6, 7, and 8 are for the g function, and 9, 10, 11, and 12 are for the h function. See, that's all that notation means. So this one says for the values of x less than or equal to 0, the value of the function is 3. No matter what number, if it's less than or equal to 0, you're going to get 3. If it's greater than 0, you're going to get 2. So these are going to be pretty simple to evaluate because the f of 2 is bigger than 2, so the answer is 2. Meaning 2 is bigger than 0, so the value is 2. These would be, okay, this is what I'm trying to, maybe some of you aren't seeing what I'm saying. That's a horizontal line, that's a horizontal line. So there's only one y value for all of those x's. F of negative 4 is less than 0, so it'd be 3. The f of 0 is for the first one because it includes 0, that'd be 3. And the f of 1/2 would be 2 because it's bigger than 0. Okay, now the g of 7, you look at the stipulations on the g function, which says use x plus 5 if x is less than or equal to 3. Use 2x minus 1 if x is greater than 3. 7 is greater than 3, so we plug it in the second equation. We're going to need to do 2 times 7 minus 1. That's 13. Okay, why don't you try a couple more and check if you get them. Okay, I did 6, 7, and 8. Why don't you check? Any questions on 6, 7, or 8? Should have 5, 4, and 8. All right, the next one we're using the h function. The h function says do 1/2 of your value x of x minus 4 if x is less than or equal to -2. And if it's bigger than -2, then you're going to do 3 minus 2 times the value of x. So I have to use the first function, or the first equation for the -4. So I'm going to do 1/2 of -4 minus 4. 1/2 of -4 is -2. -2 minus 4 is -6. Bless you. The next one is a -2. With the h of -2, we would need to use the top equation of the h function, 1/2 of -2 minus 4. It's -1 minus 4, which is -5. -1 is larger than -2, so we'll have to use the second one. So 3 minus 2 times -1. It's going to be 3 plus 2, which is 5. And last, 6 is bigger than -2, so we use the last one. 3 minus 2 times 6 would be 3 minus 12, and that's -9. Okay, how are we doing? Hope good. A thumbs up. All right, now comes the fun part. What are we going to do now? Graph it. Okay. If you like using highlighters, it would be nice to have one. Because I'm in a model with a highlighter. You don't have to have one though. Okay, so remember that f of x is like y. I am going to graph we're going to have 2 pieces of lines, okay? This number, where it says x is less than or equal to 1 and x is bigger than 1, determines which half of the line you graph. Which side of the line is on which side of what? Well, it's what side of the number 1, x equals 1, which is a vertical line. I want to find out what side of that I'm going to be on. So I'm going to highlight where the vertical line is. And it's very crooked. Oops. Well, it doesn't want to fix. Oh, well, we got the idea, right? Okay, or I kind of am weird about that. All right. Try to be a little straighter. No, I just messed it up at the bottom again. Oh, well. I'm just going to do it. So I'm going to pick one color to do one part of the line. So I'm going to have an equation for this part of the line. And I'm going to do another color for the second line part. So what I'm going to do is I'm going to say, let's make a little t-chart for values of x that we could substitute in that satisfy the inequality. Okay, so I'm going to make a little t-chart. Oh. I think I'll get it off the calligraphy pen. And now what you need to do, it says the top equation, it says do y, it's just like saying y equals 2x minus 1 if x is less than or equal to 1. So since my boundary is positive 1, I'm going to put it in the equation. All right? It does include it for this top one. So I'm going to have a solid dot when I put in 1. I'm going to put 1 into the first equation, which would give me 2 times 1 minus 1. That'd be 2 minus 1, which is 1. So I know the point 1, 1 is on the graph. So I'm going to plot it. Goes right on my boundary line. Now I'm going to put in some other numbers that are fitting the inequality. This says x values that are less than or equal to 1. Smaller than 1 would be 0. If I put in 0 in that equation, I'll get negative 1. Yes. Why is there a dot right here? Because this is going to be the included point. And when I get to this one, it's going to be an open hole. Okay? So, good question. I'm just not there yet. So I'm going to have a solid dot at this one. All right, I'll explain that because it's included. Now, I'm going to get another number smaller than 0, or actually smaller than 1, negative 1. And I did 2 times negative 1 would be negative 2 minus 1 would be negative 3. All right, so I've got enough points. And I could realize that this has a slope of 2, which is up 2, right 1, up 2, right 1. Or down 2, left 1, down 2, left 1. And that'll give me some more nice points. And then I graph that piece of the line. If you're a visual learner, the color probably helps you. Some people like to listen more than they do, or they got to watch before they write. So let me know if I'm going too fast. Okay, the second equation, I'm going to put in values. I got to start with 1, but because it's not included, but everything after it is, that's why I'm plugging it in. Okay, I can't ignore what happens on that line at 1, but it's going to be an open dot because it's not included, but it's part of the problem. So I put in 0 and I get 1. Excuse me, I didn't do that right. I put in 1 and I get 4. Sorry. So at 1, 4, I put an open circle. Okay. And then I'll put in numbers bigger than 1, like 2. That'll give me 6 plus 1, which is 7. 2, 7 is a solid dot. And then I connect. So the slope of this one's 3. Up 1, 2, 3, right 1. Oops. Or you can plug more points in. Depends on what you want to do. And there's that part of the line. But I clearly have an open dot there. Now, you can't skip 1 and only plug in 2. Because if I only plugged in 2 and then I had 0.7, I would be missing this chunk of the line. So you got to put in the boundary line number. You just make an open hole. Okay, that's one of them. We're done. Let's go to oopsie. Next one. Try again. All right, so first step, I'm going to look at the boundary number, and it happens to be 1 again. Vertical line. I'm going to do my first line, or this part. It says if x is less than 1, then do half of x. I'm going to use a T-chart for that part. So I'm going to put in numbers. I'm going to put 1 in, but it's not going to include it. This is going to be the open hole. That's not a 0, so maybe I shouldn't put it there. If I put in 1 here, I get a half. Oh, bummer. How am I supposed to graph that? 1, 1/2. Oh, well. I just did it. So it's very ambiguous as to where it really is. But good enough. It's between 0 and 1. I need an open hole there because that didn't have a bar underneath the inequality. And I now need more numbers less than 1, so I put in 0, I get 0. I'll put in -1. Oh no, that's icky. Let's put in -2. because half of -2 is easy to do. That's -1. So -2, -1. And then I'm noticing the slope of this thing was 1/2. Up 1 right 2 or down 1 left 2. So I can get some more points. Now you guys understand where I'm getting that slope from, right? The y equals mx plus b format for the equation of a line that we've already discussed. All right, ready for the right side. So I'm making a separate t-chart. I'm plugging in 1. That will be a solid dot. And -1 plus 3 would be 2. So at 1, 2, I do have a solid dot. Some more numbers bigger than 1, 2. That'd be -2 plus 3, which is 1. Oh, this thing's coming down. If I put in 3, I get 0. And then I see the slope is -1. It's going down 1, right 1, down 1, right 1. You can continue that to get a good line. That's what that one looks like. Okay, now you know why we already graphed lines, because now we're taking it a step further. All right, number 5. Let's do some different colors for fun. Okay, this one has a different boundary of 3. The top equation says for values of x bigger than 3. So I'll plug in 3, and I know that one's going to be an open dot. If I substitute in 3, I get 5. I need some more numbers bigger than 3, so I'm going to put in 4. That'll give me 6. Slope of that thing's 1, so I think I'm good to go. 3, 5, what a point? 4, 6. Notice that this wasn't the left side first. You do have to read the inequalities. They're not all exactly the same. Okay? And then the slope was up 1, right 1. And now I'll go for the other part. I'll put in a 3, and I get 0. That's where my open dot is. Put in 4. Oh, no, that's big. I need to go small. 2, -1. That one has a slope also of 1. So if I go down 1, right 1, down 1, right 1, I keep finding these points. Down 1, left 1, excuse me. It was up 1, right 1, so I'll go down 1, left 1. How are you doing? Yes. Should what be reversed? Oh. Yeah. No, wait. This one should have been, and I wrote right next to it, open. Oh my goodness. That's the part you're reversing. Nothing else, right? You weren't worried about something else, right? Did somebody have another one? Because yes, I did. I don't know how I did that. I wrote open and put an O next to it, and then I colored it in. Who knows? My brain might go off on a tangent on occasion. Oopsie. That one's supposed to be the open, and then I can fill this one in. Yes, thank you. Thank you for saying something. I actually kind of got the Florida stuff. I'm thinking of that hurricane again. To my mother. Oh my God. Whatever. Yeah, she kind of brought a little levity to the day. I was all worried about her, and then when I talked to her, I was like, oh, Mom, she'll be fine. Floating around in her apartment. Okay, sorry. I shouldn't have recorded it. That's what she said, though. Oh my. All right. How many of you are ahead of me? I had a whole bunch of people doing that in second hour, so I was just checking. All right, so we're all good with the last one though? Yes? Okay. Didn't mean to confuse anyone. Sorry about that. All right, let's go back. We got another, oh gee, we're back to the 1. Wish I put a -1 somewhere. Oh. Change it a little. You know, you can have more than 2 pieces too to a graph. There are some in the book that you have to try. I'll talk to you about that in a minute. Okay, so the first one, we've got y equals 2x if x is less than or equal to 1. So I'll put in 1 and get 2, and that's going to be my solid dot, and I will make sure I make a solid dot at 1, 2. Okay, now I'm going to put in some other numbers smaller than 1, 0, 0. Okay, that thing had a slope of 2, so we could just keep going by going down 2, left 1. You know what's kind of funny? Here's another thing I could tell you about my mother since we were on that subject today. She, Irma's coming to get Norma. Her name's Norma. She hates her name. Always has. Cursed her mother for that. Okay. X, then Y. Norma Lee. I have to tell her to watch this video so she can hear me talk about her. Okay. It's going to be 81 in November. All right. Put 1 in and, oh dear, 1/2 of 1. I'm going to get 2 1/2. And that's where my open dot is. How am I supposed to fit that on there? Squeeze it. Is that right? Yeah, if I put in 1, I get 1/2 plus 2, 2 1/2. Okay. And then put in 2. And then I get 3. Put in 4. I don't feel like putting in 3. I get 4. See, that thing's got a slope of 1/2. All right, and there's the graph of that beauty. If I didn't make any boo-boos. Nope. Looking good. I think we just have a couple more. Yes. No. Nope. I can teach this probably 3 different ways. If you were to watch Mr. Hardy's video, I believe he drafts the whole lines and then erases parts. You can do that. I mean, it's not wrong. You just would graph both lines and then you'd just erase where you got to go, too. Now you'd have to make your own. I just figured you start ripping up your paper a little bit. No. You know, you'd have to erase a lot. And if some kids don't use pencils, so this would be a lesson to do in pencils if you're going to do it that way. But I just think we can do it this way. And it works. Whatever works for you. And yes, you can do some of that stuff in your head, right? Okay, this one's got a boundary of 0. So I'm going to highlight the y-axis, excuse me. Not going to cross it, so part's going to be on that right side and one's going to be on the left. All right, so I use this first equation, x values of less than or equal to 0. I'll put in 0 for sure and get 0, 3. That's going to be my solid dot. Numbers smaller than 0, -1, get 2, -2, I'd get 1. So that's my first piece. 0, 3, solid dot. -1, 2. Then you might notice that this thing has a slope of 1. So you can go down 1, left 1, which is the reverse of up 1, right 1. I do not want to see little tiny stubby graphs either. That's why I'm modeling extending those lines. All right, and then the second part, if I plug in 0, I get 0, and that's where my open hole is. So just make sure I can tell you meant for it to be open. Then 1, 2, 2, 4. It's got a slope of 2, up 2, right 1, up 2, right 1. And make sure you connect all the way to your open hole, because it does include decimals. It's a continuous graph. And it is a function. It does pass the vertical line test. Even though it looks like it's hidden twice here, it's not, because that's where the open hole is. All set? Does anybody still need number 17? Okay, 18. You can try it on your own, see if you get it done before me. And I'll be quiet. Did anybody see something interesting that happens on this one? One has an open hole at 2, -1. The other one fills it in. So you will fill in your open hole with the second part. And then this one just steps down 1, right 1. That's how the hole can get filled in. Question? Cameron? We'll be graphing these very soon. Mañana. All right. Now we got to write one. We have to write the equation. So I was wondering, anybody had an idea how to start? Okay, got 2 hands shot up in the air. Scott? Okay, Brooke? Good. 2 great things to find. Slope, okay, so I'm going to look for, before I highlight something, I am going to be trying to write these in y equals mx plus b form. So what Brooke said is find the m, but we'll also need to find the y-intercept. All right, so I'm going to start with this one, and then Scott was right also in that we want to find out, we have to note where the boundary line is, where the break is. Or it's not really a break, I call it the boundary line because one's on one side, one's on the other. Okay, so we need to find that, which is -3. And that's the boundary line. So we know we're going to have to write an equation for 2 lines. Now this one is kind of awkward because its y-intercept isn't an integer. It looks like it's halfway between 3 and 4. So the b value for this one is 3.5 or 7/2. 3.5 or 7/2. And then I can go find the slope. I'm going to go to this point on the boundary line and climb to the next nice point, which I see it going up 1, right 2. So that's a slope of 1/2. So this piece of the graph has the equation, and you do not write y, okay? I was just reminding you of where to fill this in. This is your y value now, f of x equals. You're going to put in the slope, 1/2 x, plus your 7/2, the y-intercept. If you wrote 3.5, I would be fine with it. But I've asked you to leave things in fraction form whenever possible, or if directed. Now, I need to stipulate when that occurs is when you use this line when x is greater than, is it or equal to? Yes, because it's a solid dot, and then our boundary line of -3. That was the right side. And it doesn't matter which of these you write first, by the way. So what I'm going to write here can be flopped. Okay, not a problem. So this other one, they got a little stubby little line here. Looks like its slope is up 1, right 1. Do you agree? Up 1, right 1, we're going to have to go with that. So m is 1. Now I need the b value. So I'm going to just imagine this line continuing using the slope. Up 1, right 1, up 1, right 1, up 1, right 1, up 1, right 1, up 1, right 1. I would have landed right there at 2. Okay, so that's the numbers I need to plug into y equals mx plus b form. F of x again is the y value, so you don't write it again. 1x plus 2, and that's for values of x that are less than -3. Okay? So you're going to have to write your own piecewise. All right, now, in the book, let's look at, just to point out for you that the next page, your worksheet 2A, is the homework. That's your practice. There's some matching at the bottom. On the very back of it, it gives you the problems for the book assignment, which is page 104 to 107. Problems 1 through 4, 12 through 18. You've got graph paper there for you to do it on. Okay, so the outline for the book page is there. You will probably need to write on a separate piece of paper some of the questions, which are going to be for you to write the piecewise. I want to do one of them with you. Okay, what time? We have like only 4 more minutes. So quick, will somebody tell me, I know, I can see. Let's do, there's 3 pieces on a few of these. Let's do number 1. You got your book open already? Page 104? No? All right. I'm going to let you know, though, there are some that have 3 pieces of line, okay? You're just going to have to do 1 piece at a time, all right? You know that if you have a y equals 3, that's a horizontal chunk, so there might be like a piece of a line, stop, then there might be a chunk in between. And I will answer questions on that tomorrow.